On this RAM 1500 with the 3.6 Pentastar, P0113 means the PCM is seeing the intake air temperature sensor signal higher than it accepts. In plain terms, the module thinks the IAT input is too high electrically. The MIL may be on, and depending on the fault, the truck may have drivability symptoms or it may mainly show up as a stored code. The broad areas to keep in mind are the IAT signal circuit, the sensor ground circuit, the sensor and connector, and the PCM side of the circuit. Start with the basic system checks, and if other codes are present, check what they mean first so you do not chase the wrong direction. Begin by reading and recording the codes from all electronic control units. Save the scan report and the related recorded data, then erase the codes. Turn the ignition off for a minimum of 10.0 seconds, turn the ignition back on, and reproduce the operating conditions that set the fault. This monitor runs with the ignition on and battery voltage greater than 10.4 volts, so use the captured conditions to help you get the test to run. Then read the codes again. If P0113 does not return, treat it as an intermittent condition. If it does return, move into circuit testing. Next, check the IAT sensor K69 temperature signal circuit for a short to voltage. Turn the ignition off and disconnect the harness connector at the component being tested. Use the wiring diagram to follow the circuit path. Turn the ignition on and measure the voltage at the component harness connector with a DVOM. On a 5.0 volt signal or reference circuit, you should normally see approximately 4.8 to 5.2 volts. For this decision point, if the signal circuit is above 5.2 volts, continue by isolating the circuit and looking for a short to another circuit. If it is not above 5.2 volts, continue with the open or high resistance check for the signal circuit. With the ignition off, isolate the IAT signal circuit. Disconnect the PCM and every component connector that contains the circuit being tested, while leaving the inline connectors connected at this point. Use the proper adapter if you need to work at a PCM connector. Connect one DVOM lead to the circuit at the ECU harness connector, then probe the other circuits at that same connector. With the circuit isolated, there should be no continuity between the IAT signal circuit and any other circuit. If you find continuity, repair the short between those circuits, using the wiring diagram and any inline connectors to narrow down the location, then verify the repair and confirm the code stays gone. If there is no continuity, continue with the later connection checks in this path. Now check the IAT signal circuit for an open or high resistance. Keep the ignition off for continuity testing. Isolate the circuit by disconnecting the PCM and the related component connector. Before measuring the circuit, touch the DVOM leads together and note the meter lead resistance, because the leads can add to the reading. Measure from the component harness connector to the circuit at the GPEC adapter. The GPEC diagnostic adapter can add up to 1.5 ohms, and the decision point here is whether the circuit resistance is below 3.0 ohms. If it is not below 3.0 ohms, repair the open or high resistance in that circuit, then verify the repair and confirm the code stays gone. The next supplied circuit check is the K917 sensor ground circuit, checked the same way. Ignition off, circuit isolated, meter leads accounted for, and resistance measured through the proper adapter. Again, the decision point is below 3.0 ohms. If the sensor ground circuit is not below 3.0 ohms, repair the open or high resistance, then verify the repair. If your decision path does not clearly land you on this ground circuit check, pause, recheck the earlier diagnostic path, and do not guess your way forward. Once the signal and ground circuit checks are in the proper direction, use the fuse jumper test to see whether the PCM can detect a low signal condition. The PCM harness connectors must be connected during this test. Disconnect the IAT sensor harness connector. With the ignition off, install a fuse jumper between the IAT sensor signal circuit and the sensor ground circuit at the sensor harness connector. Turn the ignition on and read the codes with the scan tool. If the scan tool shows the sensor signal circuit low code with the jumper in place, the circuit and PCM response have been proven for that test, and the sensor is called faulty. If the low signal code does not set with the jumper in place, continue to the connection checks. For the connection check, perform any applicable service bulletins first. Disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Inspect the connectors and terminals for correct seating, damaged locks, corrosion, water intrusion, seal damage, bent terminals, overheating, push-back terminals, spread terminals, and terminal tension. Repair any conditions you find. Then reconnect everything and make sure every connector is fully seated and locked. Erase the codes. Test drive or operate the vehicle under the conditions that run and set the fault, and read the codes again. If P0113 returns after those connection checks, the diagnostic path calls for PCM replacement and programming. If it does not return, the wiring or poor connection problem has been repaired. Keep verification separate from the circuit testing. After any repair, verify the repair and confirm the code stays gone. The key with P0113 is not to jump straight to the sensor. Confirm the code returns. Check whether the IAT signal is being pulled above the 5.0 volt circuit range. Prove the signal and ground paths. Then use the fuse jumper test to see whether the PCM responds correctly. Finish by cleaning up any connector or wiring issue and verifying the code stays gone. For more diagnostic training, visit stepdiagnostics.com.